Welcome to Summarize Science. Have you ever noticed that virtual objects often feel like empty hollow shells? While AI is getting great at making pretty 3D pictures, those objects usually lack the data needed to actually interact with them. You can look at a virtual faucet, but you often cannot turn the handle or feel its weight. To solve this, researchers have developed PhysForge, a system that creates 3D assets grounded in the laws of physics. This new approach shifts the focus from just making shapes to understanding how objects actually work. The researchers argue that for a virtual object to be interactive, its creation must be driven by functional logic. They built a massive dataset called PhysDB, which contains 150,000 different objects with deep physical information. This dataset includes details like whether a part is made of metal or wood and how heavy it is. It even describes the state machines of parts, like whether a button is currently pressed or released. The framework works in two clever stages to achieve these results. First, a large language model acts as a physical architect to plan out a detailed blueprint. This blueprint defines every part of the object, from its bounding box to its specific material constraints. Second, a physics-grounded diffusion model takes that blueprint and brings it to life. It uses a novel mechanism to inject precise movement parameters, like where a hinge should be located. This ensures that the generated geometry and the way the object moves are perfectly in sync. The results are impressive, showing that the AI can understand complex objects like faucets or toy robots from just a single image. In testing, the system outperformed previous methods in both the quality of the shape and the accuracy of the physical data. It can identify that a ceramic sink basin is heavy, while a plastic toy might be much lighter. This makes the generated assets simulation-ready for use in advanced robotics or gaming. For example, a robotic arm can immediately understand how to grasp and manipulate these virtual objects. In a game engine, these objects enable rich, physics-based interactions that were previously difficult to automate. An agent could even be queried about the purpose of a specific part, like a lampshade, and give a logical answer. To recap, this technology bridges the gap between static 3D art and functional digital tools. By providing a physical blueprint, it allows AI to build a more believable and interactive digital world. By combining visual planning with physical data, the researchers have created a powerful engine for interactive content. In the future, this could be the engine that powers the next generation of smart virtual assistants and lifelike robots. We are moving toward a time when every virtual object will have its own weight, texture, and purpose. Thank you for watching this summary on Summarize Science.